So on to question 2 now. This is our organic experiment. Again, worth 50 marks, and you'll see my emails on the screen once again if you have any questions or comments about this particular question. So this is phenylmethanol. So phenylmethanol reacts in the presence of potassium manganate to produce benzoic acid according to the following equation. Phenylmethanol and potassium manganate are both solutions. However, one of them is a saturated solution. Which solution is saturated, and explain why? So for potassium permanganate, the solution is saturated, and this is to ensure that sufficient is present to oxidize all the phenylmethanol completely to benzoic acid. So as long as you have potassium permanganate said, or it could be potassium manganate, or it could be the KMnO4 could be the equation for it, formula I should say, sorry. And then that's 3 marks, and then the other 3 marks is just showing that enough needs to be there to fully react with all, to make sure all the phenylmethanol is fully reacted or fully oxidized. As long as you along those lines, you get the marks there. Okay. The oxidation reaction needs to be carried out under alkaline conditions. Why is this necessary, and what substance is added to the reaction to ensure alkaline conditions? So to ensure that you need the alkaline conditions to ensure that the MnO4 minus or the Mn7 plus is reduced to MnO2 or Mn4 plus. So if you have either of those in there, that's fine. Or you could also say that it prevents the formation of Mn2 plus. Okay, so 6 marks for saying that, to ensure that the 7 plus is reduced, Mn7 plus is reduced to Mn4 plus, or prevents the formation of Mn2 plus. And the substance added to ensure alkaline conditions is sodium carbonate or Na2CO3. Either the name or the formula is fine. The reaction was heated for 20 minutes in a water bath. Why was this necessary? So this is kind of a little bit of bonding in here. Okay, you have covalent compounds, so they're not ionic compounds. So for saying that, you get 3 marks. And then heating is required because covalent compounds react slowly as bonds need to be broken, or energy is needed to break bonds, something along those lines, that the heating is needed there because bonds need to be broken in covalent compounds. All right, so that's 3 and 3 for 6 marks. After 20 minutes, the solution was cooled by running cold water over the outside of the conical flask. The next stage of the reaction involved acidifying the solution using concentrated hydrochloric acid. This was carried out beside the sink where the solution had been cooled. What mistake was made in this stage of the reaction? Explain what the correct procedure is and why, and how was it determined that the solution was acidified. So first of all, the mistake that was made, it was that the concentrated HCl was added beside the sink. Okay, this shouldn't have been done. It should have been taking place in the fume hood. So for spotting the mistake, we have 3 marks. Then for the correct procedure, which is the addition taking place in the fume hood or fume cupboard or fume closet, is another 3 marks. And why is this necessary? And that's because concentrated HCl vapors or fumes are toxic, or they cause irritation. Then, so that's 9 marks though, there for those 3 points. And then how to determine the solution was acidified. You get a glass rod or just a rod, and you put it in the solution and touch it off. Blue litmus paper. The moist isn't really necessary as long as you just mentioned that it's blue litmus paper, which would go red, or you could use a pH meter, or you could use universal indicator. Okay, so just some way of showing that the liquid in the conical flask will turn blue litmus red, or pH meter showing less than 7, or universal indicator going red or pink. And you use a glass rod to do that. 12 marks for that. Other than acidifying the solution, give 2 reasons why concentrated hydrochloric acid was used. So first of all, to convert or change, or whatever word which is equivalent to convert. Again, if you're unsure, just send me an email of any of these answers. Okay, not just that one in particular. So sodium benzoate to benzoic acid. Secondly, neutralize any alkali or base, if you name it, to neutralize the sodium carbonate remaining in the solution. And thirdly, to provide an acidic medium to enable Mn4 plus to be reduced to Mn2 plus. So if you just mention Mn4 plus going to Mn2 plus, that's fine there. So 2 of those for 3 marks each, get you the 6 marks there. Sodium sulfite was then added to the solution. The conical flask was then placed in some ice water for about 30 minutes. Very few crystals of benzoic acid formed. What step could be taken to ensure more crystals of benzoic acid form? So you add a seed crystal, you scratch the inside of the glass, or you evaporate some of the solution. Any one of those, the 3 marks. It was calculated that the percentage yield of benzoic acid was 44.7%. If 1.05 grams of benzoic acid was produced, calculate the volume of phenylmethanol used. Density of phenylmethanol is 1.04 grams per centimeter cubed, given that phenylmethanol is the limiting reactant. So here we have our equation. This is important for the ratio of phenylmethanol to benzoic acid, which we'll see in a little bit. So first of all, you need to get the moles of benzoic acid. Relative molecular mass of benzoic acid is 122, and if you get the wrong relative molecular mass, it's only counted as a slip if you show your workings, if you show you're adding up the atoms found in the molecule of benzoic acid. Otherwise, you lose the marks for that part. Okay, so you 0.0086 moles of benzoic acid. Now we're told that that is a 44.7% yield, so that's 44.7%. So what's 100% going to be? It's going to be 0.0192 moles. So you divide 0.0086 by 44.7 and multiply by 100. Now, you could do that with the 1.05, get 100% first, and then convert to moles. So the order isn't that important. Then you look at your ratios, 3:3. So you started, so you've 0.0192 moles of benzoic acid, so you've 0.0192 moles of phenylmethanol. So then you go about converting that to grams of phenylmethanol. So again, the relative molecular mass of phenylmethanol is 108. We have the little asterisk there that it's only counted as a slip if you show your additions. So you get the mass of phenylmethanol used is 0.0192 by 108, which is 2.07 grams. Then we need to get the volume. Okay, so we're told to calculate the volume of phenylmethanol, and that's going to give us in around 2 centimeters cubed, and there's a range of values there that will give you the marks. Okay, so that's your calculation. There are 8 marks, and again, you could have come at this from different ways, and that's fine as long as you have those little markings along the way. You get to the 0.0192 moles of benzoic, the mass of phenylmethanol used, which is 2.07, and then convert that to volume. Okay, so that's question 2 in our paper completed.